So here on your screen, you have a headquarter dashboard. Also, you could call this a CXO dashboard. And so in this example here, this is a dashboard that's focused on understanding attrition at an organization. And you can see if you look at the bottom in the middle panel there, we have 8 auxiliary locations. So this dashboard has been built out to understand what's happening at those auxiliary locations. So the question is, if you're at headquarters, how do you effectively share this dashboard with each of these locations and ensure that they only see the data that's relevant to them? And we know there's multiple ways that folks are doing this right now. One that you may be familiar with or even implementing right now is that you make different user groups for each one of these locations. So here we would have 8 user groups, and you assign them properly. So when a user comes in, let's say they're in one of these locations, so say in Chicago, right, they're only seeing the data relevant to them. But there you have 8 different, for example, 8 different policies. And you can imagine for an organization that has many sites, right, even 50 states in DC, right, that's 51 policies right there. Another way that folks handle this kind of data sharing and having a security in place is by actually using the filters in the dashboard to select out to each location, putting it in a PDF and emailing it out. And this is very problematic as well, right? The whole point of the dashboard is to be dynamic, to interact with the data, and you lose all that when you're sending someone a PDF, right? It's also easy and likely that they're working from stale data, right? The PDF may take, that process may take multiple days, and the data may be updated dynamically. However, when you use an attribute, so the attribute here would be office location, you can write a single policy that you can implement. And I'm just going to scroll. So I've clicked down to a single location, and now you can filter the dashboard. So I give you 3 examples of how you could do this, but the simplest is by using, an attribute-based access control policy. In addition, using the attribute here, office location, right, you're future-proofing. So even if you had more office locations, you don't have to write a new policy. And I also want to point out, and it was mentioned earlier, but you may have but I think it's important to point out, is that here, the enforcement point for what I'm showing, the policy is actually in Databricks. So just to tell you a little bit more, I don't have a reference architecture here, but in our Power BI, when you log in, your credentials are actually passed in a call to Databricks to get data from the Delta Lake, which is the open source format where it's saved, and the Immuta policy is applied there in the cluster. And so that continues to be in the enforcement point. So when the data comes back, you're only seeing the data here. So even a user comes in through the dashboard, they see limited data. When they go in, let's say through a Databricks notebook where I'm going next, right, the same policies are applied. You don't have to put them in multiple locations. You don't have to worry about any dissonance. So I'm going to hop over there. So let me switch my screen. All right. So now I've moved over to Databricks. If you're unfamiliar with Databricks, this is what notebook view looks like. It's a place that you're able to put down Markdown. That's the kind of the text you're seeing here, images, and then also execute code. So this our notebook, where I'm going to show you actually some examples of where we're implementing these policies and what the policies look like. So I'm going to continue my use case here. So first, I'm going to show, as I scroll down, some of the actual data that's in that dashboard that I was just showing you, and then also some additional data. So that dashboard was really focused on understanding attrition. So you can imagine if you're an enterprise and you have attrition in your organization, you may want to understand why. So you might want to bring in a survey data, and that's what we're doing here. And the question is, how do you do that? How do you enable your data scientists to ask questions about why people are leaving in this example? Why people are leaving and what their survey responses are while protecting PII. And I think we chose human capital use case or HR use case because there's a lot of PII, and that's very important to protect. So kind of scrolling down, right, I already said kind of our persona here is a data scientist, and I'm restricted from seeing PII in both the workforce and survey data. And so coming in here, you can see, so in cell 5, I believe you can see my mouse, you see the policy we've written to mask PII for workforce data. And so again, policy, you probably read my screen already, but you can see here we've written, right, mass columns tagged workforce PII. So going back to the beginning, right, we've registered data and we've tagged all the data columns. And so you'll see here, the tag can be directly the column name. I have one a few cells down where I use a regex, right? But so we're starting to understand in this process kind of our data estate. So here we've applied a redaction, and here's an exception, right? Except when a user is a member of HR. We have another column that's focused on ensuring that people only have access to the data if they've gone through certain trainings. I think we could all relate to this. We have another one where we ensure that the employee ID is hashed, right? So you can imagine a lot of organizations have some sort of important key ID that you could use to disambiguate data. And finally, you can see this last line, which I think is really interesting, goes back to the cost savings, automation, and being a modern platform. So this policy is applied on any data sources where there are columns tagged workforce PII. And so instead of having to write the same policy over and over again, right, we can leverage a tag so we can automatically apply the policy to new data. So scrolling down, you can see code in this cell. It's written in Python. We've actually executed this, so you can see an excerpt of the data. That's what I'm showing you here. So this is the same data that's in the dashboard. You can see different types of data privacy and security implementations to protect the data. So we have a hash here with other things that have been regexed out. We have some nans, and we also have years at organization. They may look very round to you, and that's because we've rounded them. So here you can see the data. You can see how we've applied the policy and how we've applied it, and how someone as a data scientist might want to come in and start working with it, understanding the data. So the next part, that's the data I showed you before, is bringing in the survey data. And so here you can see my policy right now. PII is hashed regardless of user. And again, we have a tag here, mass columns with names spelled like here's a regex. So you can imagine bringing in tables from, hundreds of different tables that are stored in the Delta Lake or in the Delta Lake in other locations, right? And the column names are maybe almost the same, but not quite. So it's very powerful to be able to use a regex. And again, here we have a line on data sources tag survey data. And so you can imagine, and you don't have to rewrite this policy over and over again. We've implemented, we know other folks implement, right? You could do this potentially at the schema level, so you don't have to rewrite policies. But it's kind of easier to describe here quickly why you're applying this policy and where you're applying this policy. And same thing, we have some code that's executed here. You can see we've, again, hashed employee unique ID, and you see information about the survey. And a really powerful part that really enables a data scientist's job is the fact that you can actually bring in these two data sets that have need hashes because they have something sensitive, and actually hash them in the same project. And so the hash key is the same. So now you can join this data together and start doing data science, right? You could start either, do visuals, something simple, visualizations, lightweight models, more complex. But the idea that you can now join this data that you couldn't before because it contains sensitive information is immensely powerful. So this is just the joined table, and just scrolling down, kind of showing you some of the capabilities of Databricks, right? We're in a notebook, so we can do some exploratory data analysis. So here we have a graph showing you the data that we were looking at, and kind of scrolling down more. If we wanted to ask questions about the two data sets we just joined together and exploring the data, what we could do is go ahead and run a clustering model. And the point here, right, is what we're delivering, our analytics are not impacted by our data security that we've implemented or our policies. And I think as a lot of data scientists I've spoken with, right, a lot of times they get access to more data than they actually need, right? So they have access to PII, and it's not necessary for what they're trying to do. So there's unnecessary exposure there. And so I think it's really powerful to have the ability to write great policies and at the same time still be able to, run machine learning models. Here, this is something lightweight, more complex while protecting that data and working towards and being compliant with a zero trust architecture.